Hey everyone, welcome to Nerding IO. I'm JD, and today what we're going to go through is OpenAI's Swarm, which is an educational multi-agent system, and actually connecting it to something called Portkey, which is an AI gateway, and what that allows in the terms of observability and security, as well as some cool configurations that you can do for things like canary tests. And with that, let's go ahead and get started. All right, everyone. So we're going to look at OpenAI Swarm. They released this about a week ago now, maybe even longer. And what it is it's an educational and experimental framework that you can use to kind of start looking at multi-agents with just OpenAI. And so there's some particularly cool things that I want to go through, and then we're going to kind of look at how you can actually add observability to this and look at some security features in Portkey. So what this is actually doing is it's allowing you to orchestrate and do handoffs of different routines in the with OpenAI. And so you can kind of see right in their example right here of a transfer, so being able to hand off from one agent to the other. And what we're going to look at is we're going to dive into this example and just kind of understand a little bit of what's going on, look at some code, and then actually go through a complex example. So when we're setting up an agent in Swarm, basically you just have a name, and this is so that you can label and kind of pass back and forth to these agents. You have instructions, this is essentially a prompt, and then you have these functions. Functions are the same thing as they would be before, kind of like tools. But what you're doing here is you're transferring between agents. And then you have a run, and you basically have your message history. We're going to go through some other complex things that they have, but basically this is a very simple multi-agent. One thing to pay attention to, though, is this Swarm client. And so what we're going to do is we're actually going to look at the core and understand this a little bit better because it's really important of how we want to set up our observability. So if we come over here and we look at the core file of this Swarm, you can see that if you don't set anything, it automatically defaults to a regular OpenAI call, like an SDK call, so importing the actual library. But you can actually pass it your own client. Well, why is that important? That's important because what this means is we can actually set up our base URL. We could actually set up different models if we wanted to, as long as they're compliant with the OpenAI specification. So what we're going to do is we're going to use that to our advantage, and we're going to actually use something called Portkey, and we're going to take Portkey and we're going to connect it. So let's go ahead and kind of look at how this would actually operate. So if we go over to our example, we're actually not really changing much, right? So you can see here we're actually defining our client, and our OpenAI key is going to go into our parameter. We're going to change our base URL to the Portkey gateway, and we're actually going to go through and pass in our headers. And so what this is doing is it's instead of actually going out to a model, it's going to allow us to actually hit the AI gateway that Portkey provides. So Portkey is basically almost like a proxy or a middleman that allows you to have observability out of the box. It also has different security aspects. You can do different configurations on all different kinds of things. So you could even pass in different providers. We're going to take a look at what all of this means. But the most important thing is to know that you can define what this model or this client is, and then you just go ahead and pass it in the same as you would for your Swarm. You're just including client with it. In this example, it's just going to do the exact same example as before. It's just going to actually take an agent and do a handoff, a simple transfer, right? So basically all we're saying when we say transfer to agent B is we're actually just passing in that agent. So let's go ahead and run this. So if we do Python All right, cool. So we've already got our information that's coming back to us. The same as it was in their example. It's no different. We're just passing it again through a gateway here. So let's go take a look at what that gateway to action is actually doing. Real quick, everyone, if you haven't already, please remember to like and subscribe. It helps more than you know. And with that, let's get back to it. What Portkey is. So, all right, so let's take a look and see what Portkey is. So Portkey is just a AI gateway, but it gives you a control panel for AI apps. So one of the cool things that I like about it is it's open source, so you can self-host this if you want. But we're just going to go ahead and look at their freemium model and kind of see, you know, the analytics of what this is and go through a couple different features. So basically, now that we've actually run a request through here, what we're going to do is we're going to look at our logs. And you can see that we've had 2 OpenAI requests come through. And so when we're looking at this, all right, so what's happening here is we're actually seeing our total cost of tokens. We're actually seeing our chain, or our runnable sequence, if you will, right? Very similar to like things that are happening in Langsmith or Langfuse. We're actually able to see what's going on with our system. So we'll see the request from the user. We're then seeing, or the system is saying this part, and then we're saying our request from the user is going to transition to our agent B, and then our assistant is actually doing the function call to then say go to assistant B. And then I will fetch to assistant B, and then can you please hold for a moment. And what's happening after that is actually going out and getting that request. So now that it's actually gone through, we can actually see we wanted to transfer, we've transferred, we now have our functions. So basically between these 2 requests, we can actually see what's going on. So now what we're going to do is we're actually going to go back and we're going to see a more complicated example. So if we go into another file, we're just going to see trip planner. We're going to kind of see what's going on in this more complex example. So again, we're not changing anything other than the basic way of how we're interacting with the OpenAI client. We are then passing that client to Swarm, right? So we have our OpenAI key, we have our gateway URL, which is just through our base URL, and then we have some default headers. This is, again, used for Portkey. Now, we're actually going to define a couple of different things, and we're going to see that we have functions for get weather, we have functions for booking a flight or booking a hotel, we have instructions, so we want to know who this, that this is a traveler. We're actually going to introduce the idea, the concept of name, traveler being the default. So basically we're going to pass in context, and then we are going to look at our agents. So what we did in this one is, rather than actually having the functions hard-coded to these agents, what we've done is we made sure that they all have tools, right? So the triage agent basically has, and this is almost like our supervisor or the main agent that's going to be handling things. All this agent knows is about the weather, right? And then our flight agent is going to be acting as our booking agent, and only has access to this particular function. And we also have our hotel agent, and this one is going to be just booking our hotel. And then we're going to have all these transfer functions, and all this is doing is transferring in between. So in this example, what we're going to do at the very end is we're going to take all of those agents, and we're actually going to extend or append the functions that are associated with this. So why would we do that? Well, let's say that these agents are actually in their own class and they want to be used in different parts of the application or by themselves. So these agents can operate as individual agents on their own rather than having the transfers hard-coded to them. And then we can have a different instance where we compile all these agents together and we're strictly focusing on the ability to communicate between these agents. So you could think of these as these agents could be isolated in a different class and be called in different parts of your applications as a single agent. And then in this particular planner or overall multi-agent, we're defining our communication here. This is just a helper class, so all it is really doing is letting us know what's actually helping or happening with our tools when they're being called, what's actually going on behind the scenes. You can actually abstract that or obscure it from the user. This is our function where we're actually going to look at a run trip planner. And so what we're going to do is we're actually going to take context and we're going to pipe in user information. So you can almost think of this as like an authentication session or some other information coming from the database, or maybe even in getting this information from another chat as you're talking with the user. But right now we're just going to say this is just static context. We're going to pass all of that in. We're stating that our history is just going to be blank. We start with our triage agent, and then this is actually just keeping the history alive. So basically, we're just going to use our command line and interact with this agent. The first thing we're going to do is we're going to append the user input, and which is just this. And then we are going to start our run. We will keep our system alive. And then as we're entering things in, it'll just keep extending our messages array before it responds with our agent. So let's go ahead and give this a shot. So if we go to Python and we do a trip planner, oops. I want to book a trip, a 5-day trip to Japan based on the weather. So it knows who we are. It knows that we're going to go to Japan. It's looking for the current weather. It gets the weather, and then it is telling us it's a lovely time to visit. So first, maybe let's say based on the weather, based on get me plan. I just want to see if it'll actually put something together. So it's saying Okinawa is a good popular destination, and so let's go ahead and say, and so now it's transferring us to the flight agent, and it is booking our flight, and it is saying our flight is booked for October 27th. So this is actually 2 days from now. Oddly enough, it's actually pretty close, but we don't actually have a tool to let the system know what date it is, right? So this is probably thinking that it's October 23rd, 2023. But if we actually wanted to, what we could do is we could tell the system, either based on context variables or another tool that just says it has access to the date and time of where the user is, right? So they could have their local, for instance, or locale. Great, so now we have a flight booked. Now, my hotel. Okay, so now we're transferring back to the triage agent. The triage agent knows to transfer to the hotel agent. The hotel agent is actually going to call the book hotel function, and it's saying, okay, you are now booked for the October 27th to November 1st. So this is really cool in the sense that it is actually taking, it knows it's going to be a 5-day trip because it already has that context, and it knows that it is going to be a 5-day stay. So we're going to stay in Okinawa for from the 27th through the 1st. So I think it's funny, it's putting in emojis as well. So we could actually take this a step further, right? Like if we wanted to in the booking hotel, or maybe even in the triage, or having a some other agent, we could actually have a tool back up here where instead of just saying that this was booked as a hotel, we could actually incorporate the Stripe API. We could take that information and put together a checkout link, and then from the, let's say the web, or even from a text message or something, could actually provide a link that allows the user to click and actually goes through the process of purchasing that ticket. All of this is done because we have access to tools, and we have the ability to kind of jump between agents or do an agent handoff based on our transfers. So now what we're going to do is we're going to go back to Portkey, and we'll actually look at the observability of that system. So now I just have to refresh here. All right, so you can see that we have a lot more requests that are coming through, and every single one of these runs is actually going through the basically adding a message and then returning the entire history. So what we're going to do is we're actually just going to look at the last one, and this will give us our full context of the what is actually happening. So right here we can see what the immediate part was. It's actually looking and saying you're a hotel specialist, hotel booking specialist. It knows I'm saying I want to go through my 5-day trip. It's actually pulling out the calls that are associated with this. It's getting the tool. So every single request we now have an action here. So we can see the handoffs actually happening, right? Right here, we're going back to the triage agent. We're going to the hotel agent. We're actually seeing the information of the arguments that are being passed to book this hotel. We know that we have a check-in date. See right here where we knew, or I knew, like it's 2023. That's just October 2023 is its knowledge-based cutoff date, and so it's just thinking that's where it is. Ironically, the same day but a year later. So we know that these parameters are actually getting sent, which is why we can actually take these things and then create a link to Stripe or Expedia or some other system that could actually book this trip. Now when we see the tools here, it's actually going through the function itself. It knows what's required, right? It dynamically built out this function, which is really cool, and then actually did the transfer back to the system. Again, it's showing us our price all the way along. And then the other thing is it's doing feedback, right? So this is where you could come in and annotate how good was this response, how well was it happened. Another thing we'll be going through is at a later date, like guardrails, and well, we can just take a look at what these look like. So if you come in and see guardrails, basically you can add different guardrails to your responses. So you could do things, where is it? Like a PHI detection. You can do other things where for different biases, you can check and see if there was code that was in there. Like right here, this is really good. We've seen examples of LLMs that are spitting out code when all you're doing is asking it questions. So this is a really good way of actually being able to take your systems and put in guardrails or moderations, right? They have other things like virtual keys. So virtual keys are great because let's say that you have an OpenAI key, or I have this Anthropic key as well. If I don't want to expose this key to my system because I want to be able to rotate this key, I can actually give the port key here. I can actually change this to allow it for grabbing the virtual key as opposed to hard coding, even though this is through an environment variable. Imagine there's a system and you have these keys going in multiple different locations, and you have to rotate it. It's easier to rotate it through a control panel than it would be to rotate it in your application, for instance. So this allows you and your team to kind of rotate keys if you need to, and you just have the virtual key itself that is available. The other really cool thing in these is the ability to load balance. So if we take a look at, we'll take a look at our A/B test. These both kind of work the same. So right here, I'm actually saying what I want to do is I want to load balance these. So let's say I have the same type of, I have multiple different keys. So we'll just say, we'll just go -1 just to show an example. -2 or -3. We'd actually have three different keys. We know all of them are different virtual keys, and they're all for OpenAI. We want to say our weight. So in this instance, it's saying we're going to distribute these keys evenly. So we'll leave this one at 35, and the rest we'll do as 30. And that means that 35%, or on average 30% of the time, you'll start rotating through these keys. And you can think of this as like a great way to deal with some caching or rate limiting issues. For instance, if OpenAI only lets you do about 8 images per minute. So if you rotate that through, you can basically say, okay, well, 30% of the time I'm going to use a single key and then just rotate through these keys. The other thing that this does, though, is it also allows you to do canary tests. So we're just going to change this back so we can get rid of these errors at the bottom. And what that means is, so here, I actually want to do a canary test or an A/B test, and I want to say that 95% of the time, I want to actually use this virtual key and this prompt. And then 5% of the time, I want to start testing my Claude key, but I also want to override some of the parameters with a llama model. And so what's in this instance, or the virtual key, right? So in this instance, we're overriding, but all this is doing is saying 5% of the time, I want you to actually run a different test, and that way I can actually observe what's happening. All right, that's it for us today, everyone. So what we went through again is kind of looking at what a multi-agent architecture looks like with OpenAI Swarm, and then actually connected it to an AI gateway using Portkey so that we could look at different security aspects, observability, and even doing some canary tests. With that, happy nerding.